Let us try to understand now what is discharging of a capacitor. But before talking about discharging of a capacitor, let us start with charging of a capacitor. So let's start with the circuit which you are familiar with. And there is a battery and a circuit like this. Okay, so let us say that the switch is S1 and the switch between these two is S2. So in the first case, S1 is closed and S2 is open. So when S1 is closed and S2 is open, then this switch, it means, is closed. So the circuit could also be drawn as this. So now it has a potential of epsilon, capacitance of C, resistor has a resistance of R, and this is a positive terminal, negative terminal. The direction of current will be in this direction, and at any time t, the charge on capacitor will be some charge Q, okay, which will be positively charged in this side and negatively charged on the other side. So it will be plus Q here and minus Q here. And if I have to write an equation for the Kirchhoff's law for this circuit, it will look like, let us say I start from this point. So we're talking about Kirchhoff's law, which is summation delta V is equal to 0. So it will be epsilon minus Q upon plus to minus, and then plus to minus minus IR is equal to 0. Now after this, when time is t, let's say now that we're talking about any time infinity. At infinite time, charge will be the maximum charge on the capacitor. Okay, so the capacitor will look like this. Okay, so it will have plus capital Q minus capital Q R and epsilon, the battery. Okay. Now this is what is happening in charging of a capacitor. Okay, and this is the final situation what we have. Finally, this is what we'll get in a charging. So the capacitor will be charged to the maximum and it will have no current, and this is how it will look like. Now for discharging, in this circuit, S1 is open and S2 will be closed. So now S1 will be open and S2 will be closed. So when S2 is closed, and this is happening at infinite time when the capacitor has charged to the maximum. Okay, so now you'll have a capacitor, a resistor, and no battery involved, because now this switch will be closed and therefore it will look like this. And this switch is closed when we have this situation when the capacitor has maximum charge. So it will have a charge of plus Q, minus Q and R. So this is how a circuit will look like. So for this circuit now, at time 0, the charge on the capacitor is maximum charge. And this negative plate will have, means it has excess electrons, and positive plate means it has deficiency of electrons. So these electrons, they will move from one side of the plate. So these electrons from here, they will move and they will reach here. Okay, and therefore another electron will move from this side and it will reach here, and another electron will move and it will reach here. So then it means that this plate will be less negative now and this plate will be less positive. So any time, let us say t, the charge on the capacitor is q, which is decreased. So let's say it's plus q now and it is minus q now. Okay, and the direction of current is from positive to negative. Now you have to take care that here we're talking about the direction of electrons, but the direction of electrons is opposite to direction of current. So current is flowing in the opposite direction. So here we are drawing the direction of current. Okay. Now if you compare this circuit and this circuit, let us compare these two and see how current is behaving. Now if you see in this circuit, the current is flowing from positive terminal of the battery to positive plate of the capacitor, and then from negative to positive. So here the current is flowing from negative plate of the battery to the positive plate of the negative plate of the capacitor to positive plate of the capacitor. While in this case, the current is flowing from positive plate of the capacitor to negative plate of the capacitor. So if the current in this circuit is positive current, if it is plus I, for this direction, if it is clockwise, it is positive I when the current is from positive plate to negative plate. But here the current is flowing from negative plate to positive plate. So it means the current will be minus I. So now let us try to write an equation for the discharging circuit. So by using Kirchhoff's second rule, we know that in a loop the total potential is equal to 0. So let's talk about this loop. So let's say that we are moving from negative plate to the positive plate. It will be plus q upon c, and then let's say here we move from plus to minus, so it will be minus r is equal to 0. Okay, but now we know that the current, if this is current, should be negative of the current we already had. So because of that, we'll have plus IR is equal to 0. Okay, because the current is not IR, in actual it will be minus IR, so it will minus of minus IR. Okay, so for clarity I can also write that q upon c minus of minus IR is equal to 0, or we can write this. Okay, and this can also be written as dq upon dt into r is equal to 0. So now let's try to solve this equation. So let's take the components of t and q separately. So we can write q upon rc plus dq upon dt is equal to 0, or we can also write it as dt upon rc will be equal to dq upon q, taking an integral. Now time is changing from 0 to t, so 0 to t, and charge is changing from capital Q to small q, so it is capital Q to small q. Okay, so for this we'll get a t, so it will be minus t upon rc. Okay, so if you want to know how I got it, it could also be written as minus 1 upon rc and 0 to t, or log of q, capital Q to small q. Okay, so from here we can write it as minus t upon rc will be equal to log q minus log capital Q, which is the maximum charge, or log q upon capital Q is equal to, now let's get rid of this log, so we can say it is exponential minus t upon rc will be q upon capital Q, or we can also write it as q is equal to capital Q exponential minus t upon rc. So this is how the charge will vary with time when the capacitor is discharged. Now we can also find out current from here. So current will be rate of change of charge. So it will be capital Q exponential minus t upon RC into minus 1 upon RC, the derivative of the power of exponential. So it will be minus Q upon RC exponential minus t upon RC. Now let's try to see what this is. Now in this equation, now let's see this equation, which is Q upon C plus IR is equal to 0. So it will be Q upon C plus IR is equal to 0. Now when time is 0, charge is the maximum charge and the current will be the initial current, whatever it is. And we can write it by a symbol I with a subscript small I. So then this equation will turn out to be capital Q upon C plus initial current to R is equal to 0. So the initial current can also be written as minus Q upon RC. Okay, so it means that this term here is the initial current. So the current will be given by minus Q upon RC exponential minus t upon RC, and this is the initial current, so it will be minus II exponential minus t upon RC. Okay, so it means that the charge, it will decrease exponentially and the current will also decrease exponentially with time, and it will have a time constant of RC, and which will be constant. Okay, that's all for